reminds me I should start the recording. Can I talk about the Mars landing happening on Thursday? I have been so buried in 211 work that I actually haven't read about it, but yes, we can talk about the Mars landing on Thursday after I learn what is going on. I've heard there's something vaguely going on about Mars, and then someone asks me a homework question on Discord, and I stop reading about Mars. Missing Now says, are in-person recitations always only going to have one TA? We are going to have possibly 2 TAs and a coach starting tomorrow. We have more capacity for in-person recitation. We now have the ability to serve over 30 students at once in person in each section, which ought to account for anybody who wants to do their recitation work in person can at this point. And I will be sending instructions to people who have opted for in-person recitation tonight. So usually tonight, like in the evenings or when I go send all the announcements to all the people that they are relevant to. If you are here, if you are getting this broadcast, but you are not getting announcement emails from the class, because I know there's one person who has had trouble, please let me know. Please send me an email right now and say, I am not getting Blackboard emails, please help, because I will send out important information that way. Let me just make sure I haven't missed any other questions. Okay. In stores, post PDF. Yeah. Anything else people want to ask about the logistical aspects of the class before we talk about physics? Do you all have any questions? I wish I had some tea in my amazing, gaudy owl mug. Are there in-person labs this week? I believe there are. Ask Sam or post in the labs channel on the class Discord. So just a reminder, there is a Discord server where people ask for homework help. People do all of the other things that people do on Discord. I think I'm going to be turned into a SpongeBob meme at some point. Yeah, somebody's making a SpongeBob meme, which I will post on my door and giggle every time I walk by. Depends on what group you're in. Yeah. So the lab is a different class. It's Sam St. Pierre's in the next office over. He knows those things, and you should ask him. I only know those things when you all tell me. Okay, next question. Have any of you started to work on the homework and have questions about the homework? Give you all a moment to ponder. If you haven't started on the homework yet, that's fine. Because the stuff you need for the homework we will do today. My usual plan is, here's my promise to you for the semester. All homework I will assign at least a week and a half ahead of the due date. And you will always have at least one extra class between when we cover the material you need to do all of the homework and when it is due. So today is Tuesday. We're going to do everything that you need for homework 1 today, and then homework 1 is due on Friday. So I'm never going to say you have to have the material from Thursday's class to do the homework that's due on Friday. We don't play that game. The reason I do that is so I can talk about everything that you need today, right here, and then you have today, tonight, tomorrow, to go work on the homework, to go think, and then come to class on Thursday with questions. M. Johns, you became a little lost on the acceleration graph not being constant. Which question are you asking about? Whoop, I have 2 computers and I should scroll on the one that I mean to. So Queen Fallen Viper says you started it, but you only did 2 questions. Yeah, that's normal, right? As you can see, I do a lot of things at the last minute because I have a lot to do. I know you all have a lot to do and are also doing things at the last minute. So, no sweat. Just as you have questions, please ask us. Hadarshi says, could we please go over questions 6 and 7? So Hadarshi, could you ask which aspects of those questions you have questions about? I know we spoke yesterday. I was in the physics clinic yesterday and spoke to you. Which aspects of those questions do you have? What does dimensions mean on problem 6? So problem 6, good vacuum there. Problem 6 poses an acceleration that has this mathematical form. I'm going to madly kick my bag and coat out of the way. And the first part of the question asks, so sorry about the camera focus. Autofocus is doing dumb things. Says, what units would k be measured in? So, to figure this out, well, you tell me. How would you sort that out? And I'll ask, you all can comment on this as well. You've never encountered anything like this before, where the acceleration is this linear function in time. But you can still know things about this. Based on the units of A and T. Yeah, so Bantibal, Sydney, Nator says, find the units for both sides and cancel stuff. Let's see, what else? Christopher Vinn says, solve for k and then switch the variables and the units. Yeah, so Christopher poses an interesting solution, which is to solve for this. So you would get an expression for k in terms of A and T. I kind of like that. I that's very, very clever. But what you know is that an acceleration is measured in what units? Meters per second squared. We'll go to our bright red. Bright red doesn't show up. You all told me that. We go to white in meters per second squared. And what units is time measured in?
Seconds.
Is measured in seconds. So this constant k, well, that's what you got to figure out. But you know the units must match on both sides of the equation. And so I will let you take it from here. Does that answer your question, Hadar? In question 6, you don't know how to connect displacement and this equation in question 7. So let me pause that question until something that we will do. So I wanted to review what we did from last Thursday and extend it. And then, so Hadar, ask me that question again in 15 minutes. Great, great. Are there any other questions people have about the homework? Okay. You like my scarf, said Ferret Boy. So this is a very, very special scarf. This was made for me by Alice, my girlfriend. She is Scottish, and I am part Scottish, and I had told her what clan my family was from, and she looked up the tartan from the Scott clan, which is tiny portion of my ancestry, and she made this for me. So it is a treasure. Yes, she is made of talent. If you stick her with a little pin and you poke her, talent comes out. Which is way more talent than I do. So what I'd like to do is kind of review what we did on Thursday in kind of a different framework. So we have 3 quantities that we've met so far: acceleration, velocity, and position. And we're going to graph all of them. But first, we'll talk about their relationships. You do boop. I bumped the button on my camera. I told it to take a picture, and it doesn't have a memory card when I went to go tilt it. And it said, I can't take a picture, I don't have a memory card. But now we are back. Thank you for letting me know that. Actually, I'm going to twirl another knob that will let you see the board better. For those who know photography, I am going to go from f4 to f8 for more depth of field. And then I'm going to go from ISO 500 to ISO 2000 to compensate for the reduced light. Now you can see the board better when I step forward. So if I know an object's position, how do I find an object's velocity? So what's the relationship between position and velocity?
Velocity is the rate of change of position.
Sorry, I couldn't hear.
Velocity is the derivative of position.
Velocity is the derivative of position. So we'll draw an arrow and say derivative. And likewise, acceleration is the derivative of velocity. And I know I'm fighting the edge of my board here. What about the other way? What if I know an object's acceleration, how do I find its velocity? If I know an object's velocity, how do I find its position? I take an integral, yeah. Or an integral. What number am I working on right now? Siddiqui, we are going over kind of some general things, and we will return to homework questions. So what I'm working on here is, in the end, I'm going to get that 1/2 AT squared formula in a way that you understand. But this approach, you will also be able to apply to problem 6, where the acceleration is not constant. So Siddiqui, this is kind of a general thing. Yes, exactly, Siddiqui, exactly. What we're doing here is the thing you need for 6B. And what you all have just told me is I can go the other way by taking the integral but there are other, so integral is a fancy word from calculus. I don't know what an uwu is. I've seen it, I don't know what that means. An integral is also the area under the curve, or an antiderivative. Now, some of you are probably thinking, wait a minute, I'm just in Calculus 1 right now. I don't know how to do these things. I don't know all the fancy math. We're just starting this. And that's fine, because what we're doing here, kind of through the back door, we're teaching you all of the calculus you will need for this class. Because the idea of an area under a curve is something we don't need a calculus class to compute, if the shapes are simple enough. And Twitch chat is, so, Sad Ferret Boy, are you the one who posted the picture of the ferret in the Pets channel on Discord? Yes. So let's do physics mode for a bit to do this. So we will have times for memes. You all can meme on Discord always. You might throw time at. Yes, so Danshu 1 is Adam Alley. He is our head coach for the class. He wields the band hammer. And you know, he will just permanently ban people for being sexist and racist and any garbage like that. But if people meme too much, Adam, you're in charge. So the case that we chose to look at first was what happens when the acceleration is constant. And I'm going to figure this out in 2 different columns on the board. In this column, we're going to do things graphically. So I'm going to make a graph here of time and acceleration. We're going to make a graph here of time and velocity. We're going to make a graph here of time and position. And then over here on the board, we're going to do these things algebraically. Remember, physics is about translating back and forth between different representations of the same idea. So here's our graphical column, and here is our symbolic column. So again, this is a repeat of what we did on Thursday. We just ran out of time on Thursday, and I want to do this in a little bit more detail. So we're going to assume the case where acceleration is a constant. So this means that a is just a number, whatever it is. It doesn't change with time. What we hope to find later is a formula for the velocity as a function of time and the position as a function of time. We got to fill in those blanks. That's our task. So if the acceleration is just a constant, as it is for an object in free fall, what would this graph look like? It'd be a horizontal line, yeah. Velocity is linear and position is curved. Yes, that's what these things will be. So this is going to be a horizontal line. With a height a. And this time here, the time at which I'm thinking about this, I will label t. That's just an amount of time. Should maybe be a little more specific. This is the time axis, not the variable t. So knowing this, knowing my acceleration versus time graph is just a straight line, how do I go from acceleration to velocity? I take the integral, right. So I can think of this in a couple of different ways. It's a line with constant positive slope, yes. I want to kind of frame this in lots of different ways. So take the integral. Well, you know the integral of a constant is a line. If I think in terms of this arrow, well, this is a thing with a constant slope, right? Because derivative and slope are synonyms. So I need to draw a thing with a constant slope. A thing whose rate of change is the area under this curve. Right? So we'll highlight that in pink and say that the area is just A times T. But what you all pointed out is that accelerations really cause changes in velocity. So let me now draw a line whose slope is A. So I'm going to start here at some starting velocity. Now, over on the right-hand side, I want to label two things. How much is that? Remember, this distance here is t. So how big is the orange height there? So are we having connection problems, people?
No.
Okay.
Can you repeat that question, please?
Of course I can. So I want to know how tall this is, because the reason is we want to know this velocity at this point, and ultimately we're going to have to calculate an area under a curve. We got to figure out the area under this green curve, right? And we're going to do it by slicing it into two pieces, one of which is this, and one of which is this. So if you think about trying to calculate the area, we're going to do the area of the triangle plus the area of the rectangle. And I need to know the height of that.
You use a triangle.
Yeah, I'm going to use the formula for the area of a triangle. So what's the formula for the area of a
Half
triangle?
base times height.
Half base times height, yeah. So what is this height here? People in chat have said it's a times t. That, remember, so if we kind of do a sidebar, we know that slope is rise divided by run, which means rise equals slope times run.
Okay.
So this distance is,
You breathe it
we'll just label it
Yeah.
AT.
You sound like you're breathing. You sound like you're breathing.
And this starting velocity is v initial. So this subscript 0 means initial. So this height is just v naught. So if I'm looking at the areas, the area of the triangle is going to be, well, you told me, 1/2 base times height, right?
Yeah.
So the base is t, the height is at. So let's write this over here. V equals 1/2 AT times another t squared. And then I've got to add in this piece, add in the area of the red rectangle. Which is v naught t. So what I've done now is I knew, and I'm just going to update this to say v is t. I started with the knowledge my acceleration was constant. Whoops, what have I done? Sorry. I erased that, I misspoke. I got a step ahead. We started with the knowledge that the acceleration was constant, and we figured out that this area under the acceleration curve was a times t. So the change in velocity now is the initial velocity plus the area we worked out. I'm sorry for that. So we did the area under the curve. Now, we need to do the area under the curve again to get the position. I wrote things in the wrong spots. Let me catch up with people's questions. Area of rectangle is V naught. So that's a good question. So where did this come from? The area under the curve tells you the amount of change in something. So let's think about this not mathematically, but conceptually. Knowing the acceleration only tells you how my velocity is changing. If I'm accelerating, for instance, if I'm accelerating at 10 meters per second, that means 1 second later, I'll be traveling 10 meters per second faster than I am now. But I haven't told you how fast I'm traveling now. So JT Sheldo in Twitch chat has nailed it. They've said, why do we assume that v initial isn't 0? Because it doesn't necessarily need to be. Maybe something started moving from rest, but maybe it didn't. So if I were to drop an object, let me find an object to drop. If I were to drop this marker, right, and just let go of it, its initial velocity would be 0. But if I were to instead take it and throw it, when it leaves my hand, its initial velocity is upward, and then over time, its acceleration, pointing downward, makes it go in the other direction. Another way to write this, again, the area under the curve tells me the change. So I could say that the change in velocity, which is the velocity at some time later minus the initial velocity, equals the area under the curve, which is AT. And now, what I want is I want a formula for the velocity later. So v of t is v naught, the thing I started with, plus the area under the curve, which was AT. So, sorry for that glitch in the board. Let's go back to the other thing we were doing. We now need the position. So we saw that the change in velocity is given by the area under the curve. We'll draw this arrow here to make that explicit. So if I now want an expression for the change in position, how do I know the change in position from the velocity graph? Flex a ruler, the other thing I wrote is about to appear again, but this time in the correct spot. I do the sum of the areas, right? So just as the area under the acceleration curve told me the change in velocity, the area under the velocity curve tells me the change in position. These ideas of coordinates I will come back to in a minute that I see people talking about. So the change in position is going to be the final position minus the position I started with, and that's the area under the curve. Now, what's the area under this curve here? Satchert, boy, I actually didn't specify whether up was positive or negative. We will come to that in a moment. You always have the freedom to choose whether up is positive or negative. I use the sum of the areas. Yes, so Dunes people are saying, this is gonna be a parabola. We're going to make this here. It'll be the last thing we do. And so Jay Minchinko, Porpoise, Krithartha, other folks have said, I just add these two up. And this is what we were talking about a moment ago before I realized I'd written it down in the wrong spot. So this is This piece has an area of v naught t as a rectangle. And this piece, as a triangle, has an area of half times base times height. Area equals 1/2 at squared. So I just put down the sum of those things. Let's see, so this is going to be at plus 1/2 at squared. And that means that my formula for x of t, I simply put everything on one side. Whoop. This should have been v naught t. My formula for x of t is going to be my initial position, which I put on the other side, plus the term that comes from, I've gotten my color coding backwards. All I'm doing here is changing colors to keep my color coding consistent. So I have the term that comes from the pink rectangle, plus the term that comes from the orange triangle. So there we are. What did we do here? I've written a bunch of stuff on the board. Well, let's do one last bit. This is a parabola. I can't do its area in such a simple way without, using middle school geometry, but I can draw the picture. We don't need to take the area under the parabola, but this gives me something like so. We started with the knowledge that the acceleration was constant. We took one integral. We looked at the area under this curve to get this line. The integral of a horizontal line is a sloped line. The area under this curve, looking at it mathematically, is a times t. So the formula for the change in velocity is at, telling me that the velocity as a function of time is v naught plus at. And then I said, okay, now I have this graph. Let me take one more integral. Look at the area under this curve, and many of you would say, well, I know how to integrate this. I've taken calculus. You do, but the way that you know that is by looking at the area under this curve. So it's important that we look at this geometrically for students who are just now taking calculus. Oh, did I write something? Oh, I did get stuff off camera. Boop. Now I have fixed it. We took one more integral and got this formula. So, really, we've come up with a powerful series of results. If you know an object is moving with constant acceleration, you know where it is at any time later. Lumbo asks, why is v of t different from delta x? So this expression tells you the velocity at some point later. So if I'm accelerating, this will tell me at some moment in the future how fast I am traveling. But delta x tells me how far I have moved. So I know that if I start at some position x naught and I am accelerating, so suppose I have an object that I throw up in the air. I have like a ball or my keys or whatever it is, and I yeet them up in the air. This is the starting position. This is how much the position changed owing to the starting velocity, and then this is how much the position changed owing to the fact that it's accelerating. Let me look. Adam is letting me know that I'm off. So Michael had said, somebody let him know that he's off the screen, especially today where I came in all discombobulated with icicles in my hair, quite literally. I will make mistakes. I will make mistakes in mathematics, and I will also make mistakes in tech. Just please tell me what they are, and I'll fix them. I'm A-okay with doing that on the fly. So what I'd like to do now is I'd like to erase this and talk about this now in more symbolic terms. So I'm going to make these graphs go away. Again, this recording will be available. I have stuff set up to transcode it, so this recording and Thursday's recording will, Thursday's recording is actually already on YouTube, but they'll also go up on Blackboard Collaborate, or on Blackboard today. So, we're going to erase these things. And now, rather than doing areas under the curve, I want to talk about this in calculus terms. So, instead of saying integral is area under the curve, we're going to do integrals like we've learned in calculus class. And if you haven't done integrals yet in your calculus class, don't sweat it. Yes, Dunas, quick maths. I will send out the YouTube link after class. If you Google Syracuse University Physics 211 YouTube, you will find Thursday's class. I just haven't posted the link yet. It took a lot longer to upload over my home internet than I thought, but I will do it from here, and we will get things fixed. So if I want to go from acceleration to velocity, I want to take the integral. What's the integral of A? Yes. So Beck-Munch said AX, because you're used to always integrating with x being the horizontal axis in calculus class, right? But often in physics, the independent variable is time. So this is AT plus a constant. Did I hear one of you say that?
Yeah, plus C.
Plus a constant, yeah. Because you learned in calculus class you're supposed to put a constant on. Sad ferret boy, we will be doing dot products later in this class, but not cross products. The cross product is all a lie. You can tell your math teacher that your physics professor said that the cross product is a lie. But in physics land, we don't just like throw around constants. They mean something. What is this constant here? What physical reality does this constant have? Again, in math land, where the letters don't stand for anything, it's just a thing you bolt on. But yeah, in physics land, this is really the initial velocity. Well, I can't use that color chalk because it doesn't show up. That's V naught. Okay, so now I figured out that V of t is AT plus, whoop, V naught. Okay. Let's do it again. The position is a function of time. How do I get that from velocity?
Integrate again?
I integrate again, yeah, exactly. So I want the integral of AT plus V naught dt. Somebody tell me what that is. So Luke J. Terrace 10 has said it's 8t squared over 2 plus V naught t plus c.
Mm-hmm.
Is that what you said? That's what you said?
Yeah, I started saying that.
Ah, yeah. So if I could make a request, when you all are saying stuff to me, talk a little bit louder, because I can't hear out of this ear, so it's sometimes hard for me to hear over background noise.
Okay.
In the auditorium, it's always a pain. I'm like, person in the back, everybody else be quiet. I can't hear the person in the third row from the back who is saying very intelligent things that I can't hear. So yeah, this is the integral of this term is 1/2 at squared. The integral of this term is v naught t, and I'm supposed to put on another constant. All right, Kritarth has already figured it out. This constant here is initial position. This is just x naught. So you see that in both kind of the symbolic thing that you do in calculus class and the graphical thing that was here before I erased it, we arrive at the same results. Somebody, I believe it was, okay, so pause. Sad Ferret Boy has said, but geometry is harder than calculus. Oh, flexor ruler, this big elongated S means integral. It is a stretched out S for sum. This is a notation that was hundreds of years old. This question about geometry being harder than calculus. So here's the deal. Everybody studying anything has different ways they like to think about it. The brilliant thing about physics is there are many correct ways to think about nature. All of them are right. Some people prefer to think about things in more algebraic ways, more like symbolic mathy ways. Some people prefer to think about things in more geometric, picture-y ways. Both of those are correct. My personal bias, the way my brain works, is really far on the geometry side. That's just how I work. But I present you with both perspectives because all of them are correct ways to think about physics. So however it is that you would like to do something, all of that's right in our class. You know, I happen to be somebody who's really far on one side of the spectrum of likes symbols versus likes pictures. But if you are on the other side of that spectrum, that just means you have a different correct approach than I do. When I was a PhD student, we had a very difficult problem to do that involved a bunch of vector calculus and a bunch of difficult things we had to do. And my symbolic math background was really, really weak when I was in grad school. I was really bad at this kind of stuff when I got to grad school. And me and a friend of mine were sitting we were like, it was past midnight and we were doing this problem, and he was like grinding through these pages of vector calculus, and I couldn't do what he was doing, so I had instead like torn a little loop of paper off of the side of my notebook, and I was wrapping it into things to represent these ideas in vector calculus. It was a thing about magnetic fields. And I was writing down a paragraph of text, right, of what I was doing with my little strip of paper. And we got to the end of it, and my friend Caleb said, I think I figured it out. And like 30 minutes later, I said, I think I do too. And we went through, and the things I had done with my little piece of paper and represented in words, Caleb had represented in symbols, because this is the thing he's really good at, is algebraic analysis. And I learned so much from him. He explains to me all of this algebra I didn't know, and vector calculus I didn't know. And he saw how it was represented in me looking at this little loop of paper from different angles and writing down what I saw. All of these things are valid, and in physics you have a lot we can learn from seeing multiple perspectives on the same idea and letting them inform each other. So there's my philosophy rant for the day. Okay, I'd like to return to a comment that was made a while back by, who asked? Oh, about part 6b. Somebody asking about that in the homework. Siddiqui. So, Siddiqui, does this help you understand how to do 6b? So, question 6b on the homework, and if you have not yet taken calculus, don't worry too much about this problem. This one is kind of in here as a bonus for those people who have taken calculus. But if you haven't taken calculus, we're not going to grade you off for not doing that problem. I've given you that the acceleration is kt. Now in this problem, the acceleration is a function of time. This is different. It's not constant anymore. But in 6b, if it's not constant, how do you deal with that fact? Yes, said Ferret Boy, jerk is constant. So the thing that is the derivative of acceleration is called jerk. Like, you jerk, but also my car jerked when I hit the accelerator. It's not an idea that shows up in the laws of nature, but that's what K is called, is jerk. But if I know this, how do I get velocity from that formula? Siddiqui, you say you figured it out. Could you? You take an integral, yeah. And how do you get from velocity to position? Say again?
The same thing.
The same thing, yeah. So really, all that problem is asking you to do is to take two integrals of an easy function. Dunes, there is our poetry for the day. A jerk is a tug is a boat, boats go in water, water is nature, and nature is beautiful. You will fit right in with the sentiments in Astronomy 101. You have no clue how displacement looks. Well, you have a formula here, just take one more integral of it. So we have our three constant acceleration formulae here. Now what I'd like to do is talk about how to solve problems with them. So Julia C. Kopak says, can we integrate? Sirath says, what does dimensions mean? So let me grab your questions. Yeah, so Chunky Funky Monkey, just don't go there. Innuendo in Twitch chat, not cool. Julia C. says, let's talk about how to do this integral. So I'm not going to do it, but I want to remind us of how to integrate monomials like this. The hint that I give you is that the integral of some number, I'm just going to call it c, where c is some number, times t to the nth power is, so what do? You increase that power by 1, and then you divide by it. So this is ct to the n plus 1 divided by n plus 1. So let's do a couple of examples. Suppose I told you that the let's look at this one. We had at. Suppose the initial velocity is 0. So here, the thing out in front is a, and the power is 1. So the integral of at to the 1, well, what am I supposed to do? This goes up by 1.
And then you divide it by the new power.
And I divide it by the new number, exactly. So this is 1/2 at to the 2, which is the thing we just did.
However.
What if I gave you just make up a new one. What if I gave you the integral of kt to the 5? What would that be?
KT to the 6 over 6.
Kt to the 6 over 6. And if I have several of these added together, plus c, yes. And you would identify that as something else. So then if you integrated this again, this would go up to 7. You'd get 42 down here.
Right.
And then this would turn into c times t.
Yeah, and then plus d.
And then plus another constant, yeah.
Yeah.
So let's actually do that. So the integral of kt to the 6 over 6 plus a constant. So here, this is times t to the 0,
Right.
right? Which is just 1. So if I were to integrate this, what does this term turn into?
KT to the 7 over 42.
Kt to the 7th over 42. And then what does this turn into?
Plus CT.
Plus ct, because this power goes up by 1, right? And then I divide by it, but dividing by 1 doesn't do anything,
Right.
so that just gives me ct.
Then plus the constant of integration.
And then I have another constant, d. Now, we identify these constants with things like initial position and velocity, so when you do this, it's not going to be c and d, it's going to be
X naught, V naught.
x naught and v naught. Yep. Because remember, in physics, your math means something. So this is literally all the calculus you need to know for our class. All right, we have 15 minutes left, and I would like to work on using these ideas to solve some problems. In the rest of class, I'm going to be asking you all to fill in some blanks. And I want you to tell me in Twitch and Zoom chat what goes in the blanks. So, our first problem is we just have a person standing at the edge of a cliff. The cliff has some height h. I shouldn't use that color. I know red doesn't show up well in Zoom. And this person, it just drops an object. So, person drops a ball from a height h. How long does it take to hit the ground? So this question is pretty easy. And people are typing stuff, but here's what I want to practice. When you see things like this question it's sometimes not obvious what algebra to do. So what we're going to practice is translating these sorts of questions into sentences about algebraic variables. So you practice this in recitation. You're going to practice it again in recitation tomorrow, and there's this on your homework. Let me write this down. Translating questions like this into statements like this that have got variables in them that then tell you what algebra to do. So you tell me, what kind of sentence could I write like this that answers that question. Sad Ferret Boy says, do you have to translate every homework question? You don't have to write out the translation, but every time you have something like this, every time you have a question about nature written in natural language like English, you will need to think of a way of phrasing that question in terms of mathematics that you can then calculate. So no, we're not going to like make you write this stuff down for credit, but this is a thing you will need to know how to do, and sometimes we will ask you to do it for credit. My experience has been that this step is the cause of probably 50% of missed credit on exam one. So, Sledix, I guess I'm pronouncing your Twitch handle correctly. What is the value of t at the time that the position, remember h is the starting height, so we need another letter for position, is equal to 0. T when h equals 0, so when the height is 0. Implicit in your answer, right, we have to choose which location here is 0. So what position are we going to choose as 0 in this problem?
The ground.
The ground, okay, that's kind of implicit in this choice. You have, when you told me this, you've kind of implied that this line is x equals 0. All right, so now this sentence ought to tell you what mathematics to write down. So I am supposed to find the value of time at the time that x equals 0. So how do I solve this? Well, I have an expression for position as a function of time. Right?
Yeah.
It's the one we just worked out. So actually doing that, I know position as a function of time is initial position plus this term plus 1/2 at squared. I've got to fill in all of these blanks. What's my initial position in this problem?
We don't know.
Sorry?
We don't know it.
You don't know it. Do you know it?
I mean, like the number, no.
Ah, good point. I'm so glad you asked that. We don't have a number value, but that's okay.
Right.
Algebra lets us talk about things even though we don't know the numbers. I've told you the cliff is some height h. You don't know a number for h, but you can get an answer in terms of h. So in this class, in all of your scientific life, if somebody says like, the height is h, we want an answer in terms of this. So this is just going to be the starting height. What about my starting velocity? Sad Ferret Boy is a step ahead of me. Drops implies that V naught is 0
Yeah.
because this is being dropped rather than thrown. Right? If we were throwing it downward, the starting velocity would be something different. Also, what about this? Let me just switch colors. What is the acceleration here? Do I know anything about the acceleration of the thing? It's gravity. Yeah, it's in free fall. So the acceleration here, well, we have a choice to make. Which direction is positive?
Going up.
Going up. So you want, in this problem, you want this way to be positive?
Yes.
Okay. Acceleration then, is the acceleration going to be positive or negative?
Negative. So
Negative.
nine.
So minus g. Here is a thing, so this might be a little bit incongruous to what you did in high school. G is always a magnitude. The value of G is 9.8 meters per second squared. And let's write this. This is the acceleration due to gravity on Earth. It is a magnitude, it's a positive quantity, and its direction is down. Now, sometimes down will be positive for you, sometimes down will be negative, but G itself is this. So this means that x of t is h minus 1/2 gt squared. We take a look at this, we do a gut check, and we say, all right, I'm starting at some height. This is positive, this makes sense, so my initial position is going to be up in the air. But I'm accelerating downward. Everything works out. Shane says, why is x naught h? Because the object that I am dropping starts from up on the cliff. So here is where we start, and we move downward. Are we ignoring the extra height between the cliff and the person's hand? Yeah, okay. Yeah, we are. Flexor ruler, since the ball is falling toward gravity, does it matter more if it's negative or positive? You may choose anything. You may choose either direction to be positive. So here, we chose this initial position, x naught, to be plus h, because you all told me to, right? You told me that this way is to be positive. Right? When you told me this starting position was positive. That means that the direction of gravity then is negative. And you have the freedom to choose either way. Sad Ferret Boy says, now we solve for t. Yeah. So we solve for t. We get h equals 1/2 gt squared. T is the square root of 2h over g. So there's our first physics problem, where we have calculated a quantity like that. I want to talk in our remaining 6 minutes about another sort of thing like this. While I'm erasing the board, let me address 2 questions that have come up. Sad Ferret Boy says, should you use g or 9.8? You should always, in this class and in every other class, wait to plug in numbers until you're ready to do something with them. So there's a question in problem 1 on your homework that says, when should you put in numbers? And the answer is only at the very, very, very end. Porpoise in Twitch chat just said, we can wait to put in the number until we're ready to do the arithmetic. Yes. So often in this class, we will just write g. Because as soon as you put in the number, you have forgotten where it came from. You've forgotten that that expression has something to do with gravity. So now what I want to do I want to imagine 2 people. This again has a height of h. And this one, person on the bottom, is going to throw a ball upward with an initial velocity of v naught. We've got 4 minutes left, so I'm going to be a bit quick, but there's something I want to get to. The thing we want to ask is, how fast is the ball moving when the top person catches it? So again, we have to translate this. So our template for translating this, sad ferret boy, the final answer should have G. Our template, remember, is what is the value of blank at the time that blank equals blank question mark. I have 2 points that I want to make. I have 3 minutes to make them. Both of these are important. So Porpoise says, what is the value of v when x equals h? Yeah. Oh, let me get my sad broken chalk. What is the value of v at the time that the position equals h? You've chosen to use the same coordinate system, right, where you've chosen this line to be x equals 0, and you've chosen this way to be the positive x-axis. Yeah. But so this is how, how one translates this. I want to know the velocity at the time that the ball is here. So my template now tells me that I want to figure out the time that x equals h. So find the time that x equals h. All right, well, x of t equals x naught plus v naught t minus 1/2 gt squared. And since you've chosen x equals 0 to be down here, this term is 0. Now, this is the last point I want to make, and I have 1 minute to do it. I want to know when this is h, so I have h equals v naught t minus 1/2 gt squared. What do I do with this equation? Why is it minus, Bridget? It is minus because we chose up to be positive in this problem, so the acceleration of gravity is pointing in the negative direction. Bridget, let me know if that answers your question. How do I solve this equation? Give you a hint. Well, we'll put everything on the left-hand side. 1/2 gt squared minus v naught t plus h equals 0. What's this? This is a quadratic. It has 2 solutions, and you will need to think about them. There's a question on your homework that touches on this, on dealing with the 2 solutions you get from the quadratic formula. As you get to that question, think about it and ask me for hints on Thursday if you like. Yes, Porpoise. 1 on the way up, 1 on the way down, and you have to consider which one is which. We're out of time. I will hang around and answer anybody's questions that you may have, but this is the end of our formal class. We will see you in recitation tomorrow. If you have asked for in-person recitation, I will send you instructions on what to do tonight. But expect to come to in-person recitation if you've asked for it. Thank you, world. I apologize for coming in sort of with not my hair on fire, but my hair full of icicles late today. Sorry about the missing 1 minute at the beginning. Thank you. I will see you tomorrow. I may be in your recitations. I will be here helping to organize things. Shogunite, you can just call me Walter. Dr. Freeman works too, but call me Walter if you like. Thank you all. Yeah, Kruthartha says it's quadratic. I'll hang around and answer anybody's questions that we have. Thank you, Maxiplier. So Maxiplier, is your name perhaps a reference to the YouTuber named Markiplier? Thanks, Elizabeth. Thank you, Miles. Yes, Markiplier is pretty funny. I'm going to end the recording